Hi there. In this lesson, we are looking at normal distribution. We know normal distribution curve is a bell-shaped curve, and on the x-axis we have the scores, and on the y-axis we have the frequency. But rather than showing the scores themselves, we can show them in the form of their z-score. So a z-score of 1 means we are away from the mean by 1 standard deviation. A z-score of 2 means we are away from the mean um, double the standard deviation, and so on. If your score is more than the mean, then you have a positive z-score, and if your scores are below the mean, you have a negative z-score. And also we know that 68% of all scores lie between minus 1 z-score and 1 z-score. In other words, they are only 1 z-score away. If you are only 1 z-score away from the mean, that means you are 68% chance that that score lies in this range. And there is a chance of 95% that a score lies within two z-scores or two standard deviation from the mean, and there is a chance of 99.7% that any given scores lies between three standard deviation over the mean and 3 standard deviation below the mean. All right, with that short introduction, let's look at a given problem. In a mathematics test, marks are normally distributed. John has a mark of 70 with a z-score of 1, and Tina has a mark of 40 with a z-score of -2. Find the mean and standard deviation. One way of approaching this is quicker and mentally can be done, at least for this case. So when we're talking about a z-score of 1, because John has a z-score of 1 and Tina has a z-score of -2. There is a difference of 3 z-scores here, and that means 3 standard deviation. And in actual terms, their marks are 30 away because you got 70 for John and 40 for Tina. So 30 scores, 30 points are away, or 30 marks are away. 30 marks are of being away in this case means 3 standard deviation. So each standard deviation is just 10. And then from that we can find the mean using the definition of z-score. A more formal way of doing this is just subbing in the formula for the z-score. Z-score is for any score is that score minus the mean. Then for mean, I've used here the notation mu, but also you can use x bar. X bar means mu. This is mainly used in probability. Mu and x are the same thing, one in the case of probability and the other one in the case of data. Anyhow, so z-score is x minus x bar or x minus mu over sigma. So for John, z-score is 1. So 1 is equal to 70 minus x bar over sigma. For Tina, z-score is -2. So -2 is equal to Tina's score, 4 minus x bar divided by sigma. Now we have two equations with two unknowns, which are x bar and sigma. We need to find them. So from each equation, I find the value of sigma. I make sigma the subject. For this one, sigma becomes 70 minus x bar by cross multiplying. For this one, what I've done, I switched the places of minus 2 and sigma to get to that. So sigma is equal to 40 minus x bar on minus 2. And now we equate the values of sigma from these two new equations. We get 70 minus x bar is equal to 40 minus x bar on minus 2. Cross multiplying, you get minus 140 plus 2x bar is equal to 40 minus x bar. And taking x bars to one side, we get 3x bars. And taking numbers to the right hand side, we get 180. 140 plus 40 makes 180. Dividing both sides by 3 gives us 60. So x bar is 60. Now substituting in the first equation, we work out the sigma, the value of sigma. So 1 is equal to 70 minus x bar, which is 60 on sigma, and cross multiplying will give us sigma is equal to 70 minus 60, which is 10. That is how we find the value of sigma and the mean once they given us two scores with their positions in terms of z-score. Thank you very much for your attention.